everybody. This is Cassie from the Children's Place at the Wood County District Public Library, and as you can see, we're going to do some science today. I want to welcome you guys to Summer STEM. We're going to be trying to do a video a week as a STEM program for you, and this is our very first one, so we're really excited for you to join us. Our summer reading program theme this year is Imagine Your Story, and it's all about fairy tales. And fairy tales can be interesting to tie into science, and here's how we're doing it today. In a lot of fairy tales, you meet an evil queen or an evil witch, and they are brewing potions and poisons for some purpose or another. When you're actually doing chemistry like brewing something or cooking something, it's really important to know the ingredients that you have and how they're going to react with each other, because sometimes certain elements should not be mixed together or the results could be explosive. And we're going to talk about that a little bit more today. I am joined by a friend. This is my friend Todd from Lubrizol, and I'm going to let him introduce himself to you.
Hello, I'm Todd. I'm the Quality Control Supervisor at Lubrizol Advanced Materials here in Bowling Green, just right next to Kroger. Beautiful pond in front with a bunch of geese. We make soap, and we make lots of it.
And soap is really important these days, and we will be talking more about soap with Lubrizol later this summer. So today, we're going to go ahead and get started, and I'm going to move some stuff out of the way so that we have a little bit of a clearer picture. And we'll get back to all of these bottles that I'm moving in a little bit. So, I know a lot of you who have come to STEM during the school year will be familiar with what happens when you mix baking soda and vinegar. It's a classic experiment. So what I have right here in this bottle, I have half a cup of white distilled vinegar, and in this balloon, I have 2.5 tablespoons of baking soda. And what I'm gonna do is I'm gonna put this balloon over the mouth of the bottle very carefully, just like that. And I'm gonna dump it in, and we're gonna see what happens. So, if you've done this before, you know what's gonna happen, and if you haven't done this before, I want you to try and guess right now. What's gonna happen when I dump the baking soda into the vinegar? Here we go. All right, so, oh my goodness. I don't know if you can see, but those bubbles went up really high. And I was actually getting some of that solution into my balloon. But now I think we're good. I've actually still got a little bit of baking soda that hasn't fallen out. So as you can see, my balloon expanded, which is interesting. Why do you think that happened? I wonder if Todd has a reason why all of a sudden my balloon is filled with air when it wasn't before.
Maybe the substances that you mixed together, maybe they changed.
That's right.
Maybe there was what do you think?
I think we've created a chemical reaction. So when you combine two things together, there's two different kinds of reactions. You can have a physical reaction and a chemical reaction. With a physical reaction, like putting salt into water, I can separate those out again and I can have water and salt. But when you have a chemical reaction, something different happens, right, Todd?
That's right. You make a whole new substance. You make different substances than what you started with.
And in this case, we've made carbon dioxide, and that is what has filled my balloon. It's carbon dioxide gas. So I was thinking about this because this is a pretty simple experiment. And I was in my kitchen doing some cooking, and I realized that I have a lot of different kinds of vinegar in my kitchen, and you probably do too. I had 5 different kinds of vinegar in my kitchen when I looked, and I started to wonder, would it make a difference to the size of our reaction if we used a different kind of vinegar with baking soda? And I thought, you know, maybe I should do an experiment for STEM. But we want to make sure when we plan an experiment that we're using our scientific method. And so I know Todd knows all about that because he is a scientist. So he's going to take us through it step by step as I talk about how I've designed my experiment through all 5 steps of the scientific process. And then we're going to conduct this experiment.
All right. So the 5 steps were to ask a question.
Okay, so my question is, does the type of vinegar affect the size of the reaction?
Then you can form a hypothesis.
So my hypothesis is, I think that the kind of vinegar used will affect the reaction. I think some kinds of vinegar will make different amounts of carbon dioxide gas.
So how did you design this experiment?
Well, I have my 6 different kinds of vinegar. I have my white distilled vinegar, which I'm using as my control. So that means that this result is what I'm going to measure all the other results against. And then I have my other vinegars here. I've got white wine vinegar, I've got rice vinegar, apple cider vinegar, malt vinegar, and balsamic vinegar is my last kind of vinegar. So what I want to make sure I do as I test this experiment is I want to make sure that I'm only changing one thing each time I try, because otherwise our results are going to be kind of skewed. So I've made sure that each time I have vinegar in one of these bottles, I have a half a cup of vinegar. And in each of the balloons in front, I have 2.5 tablespoons of baking soda. And that way I know that the reaction size is going to be determined by the kind of vinegar and not something like having more vinegar or more baking soda. Because that's important when you're designing an experiment, right?
Absolutely.
Even
control is important.
Yeah. Sorry, go ahead, Todd.
No, control is important because it allows you to minimize the number of changes in the other variables, and it lets you really draw actual conclusions from your data.
That's right. So I've even got the same size and shape bottles and the same color of balloons, even though that probably won't affect the outcome of the experiment, but you never know. All right, so what I'm going to do to measure our results is I'm going to measure the circumference of the balloon once it's filled with gas. And I'm going to have Todd write down our results. So I'm going to measure this around the widest part of the balloon. And I'm going to do it very carefully so that I don't spill any vinegar. At least that's the hope. So this is 47.5 centimeters.
I got it.
All right. So now we're going to move on to white wine vinegar. I'm going to put my balloon over the top of the bottle, and then I'm going to hold on tight. Oh, here we go. Make sure we get all the baking soda out. Down into the bottle. All right. And again, I'm going to measure around the widest part. All the way around. It would probably be really helpful if I had an assistant to do this. And maybe if you try to do it at home, you would have an assistant. But we're practicing good social distancing, so I'm by myself. And this one is 48.5 centimeters. All right, now we're gonna do our rice vinegar. Here we go. Okay. This one's taking more time for the reaction to occur. So that's some interesting data. And I've definitely got more of that solution going up into the balloon than I did with the other ones. Interesting. That one is much more active and volatile than the others. But I think my balloon does not seem to be getting any bigger right now, so I'm going to go ahead and measure it. That one is, oh, lost hold of it. Hang on. Oh dear. Like I said, if you try this at home, it's going to be helpful to have an assistant. This one is 45.5 centimeters. All right, that's 3 down, 3 to go. Next, we're testing apple cider vinegar. Oh, goodness. All right. Ooh. So, apple cider vinegar is gonna hit. Oh dear. Gotta be careful. Science can be dangerous and messy. I need a third hand. That's a science experiment somebody should get on. How to help us grow another limb. All right. This one is 48 centimeters. All right, 2 left. This is malt vinegar. Here we go. Ooh. Oh, that's an interesting, I don't know if you guys can see this, but the consistency of that foam is very different from the others. And there's definitely a lot more of it that was created, and it's more solid. So it's actually kind of filled up my balloon halfway. I don't know if you can see that with the air behind, the light coming through, but I've got like foam halfway up my balloon from that one.
Wow, that's neat.
That is, and this one, the balloon is really top heavy, so as soon as I let go of this, it's gonna tip over. And this one is 40 centimeters. Okay, Mr. Malt Vinegar balloon is gonna cause some problems for me. So I'm actually gonna pass this one over here so that my assistant can come get it and go put it in the sink. Because as soon as I let go of that, it's gonna tip over. And we do not want that to go on our carpet. So the last one here is balsamic vinegar. All right, here we go. Oh, and this is doing very similar to the malt vinegar. You can probably see that one a little bit better because it's so much darker.
A hypothesis that you could come up with after this is maybe balsamic and malt vinegars are similar.
Yeah, how are they similar? And I do have the bottles here so we can kind of compare what the ingredients are and what makes malt and balsamic different from the other ones. Okay. I'm also going to be handing this one off to somebody off camera because it is doing the same thing. And this one has a circumference, oh dear, of 51 centimeters. My apple cider vinegar did go tumbling, but it's not up in the balloon as much, so it did not make a mess. Okay, my goodness. Those are some interesting results to talk about. So, I'm going to pass balsamic off camera, and the others I'm just going to move out of the way. So Todd has written down our amounts. So go ahead and read those results back to us, Todd.
All right, so the white distilled vinegar, which was our control, we got 47.5 centimeters. The rice wine vinegar, we got 45.5. The white wine vinegar got 48.5. The apple cider vinegar, we got 48. The balsamic vinegar, we got 51. And the malt vinegar, we got 40.
So there was definitely a difference depending on the kind of vinegar that we used, right?
Absolutely, yeah.
So I think our smallest one was 40 and our largest one was 50 centimeters. And now when we're talking about this data, there are some things that we have to keep in mind. And one of them is, if we were going to draw some actual conclusions from this, we would need to repeat the experiment. You can't just take results from doing it one time and say, here we go, this is the fact. Because that's not always how science works. Repetition is what gives us as close to truth as we can get from science experiments, right?
Absolutely. It's really important that you don't just take one set of data as your evidence. You always have to prove that your test is repeatable. If your test is not repeatable, you can't draw any conclusions from it. So a repeatable test will actually give you something you can learn from and make new hypotheses from.
Yeah, so I can say from this experiment, I think my hypothesis is true because I guessed that it would affect the difference. I think that what I said was true, but I would have to test this again, and I would probably want some more exact equipment because you also have to take into account human error, and I don't know for sure that I was measuring the same part of the balloon every time, and as you guys could see, I was having trouble sometimes getting the tape measure around the balloon, so my readings may not have been exactly where we wanted them to be. And so that's important too. In a lab like you would have at Lubrizol, you'd have all sorts of fancy equipments where you could actually measure the amount of gas created. I don't have that here at the library. I've just got some balloons. But we could set this before a scientific lab and go, I want to know more about this. Can we use your special equipment to get some more exact results? But I think I can say that my hypothesis, I think I'm onto something. I think the kind of vinegar has some effect on the size of the reaction and the kind of the reaction. Because I was also noticing that the foam that was created from my different types of vinegar was different for the malt vinegar and the balsamic from the other four. And I think that's because the malt vinegar and the balsamic vinegar actually have things added to them. The other four are just straight vinegar, right? But the malt vinegar has added, let me find my ingredients. Oh no, this is just malt vinegar, but it's made in a different way. But the balsamic vinegar it's got concentrated grape powder in it, and it's got some coloring in addition to red wine vinegar, and that's what makes it balsamic. So there's some other ingredients here. And it's also important to note, as I'm looking at the ingredients, this one says that it is 6% acidity. This one is 5% acidity. This one is 4% acidity. So they've got different levels of acidity, and that might also be affecting my results. So there's a lot of conclusions we can draw from the data, but we can't absolutely for sure say this is how it works without doing some more experiments, right?
Absolutely.
All right. So, Todd, why don't you tell us a little bit in our last couple minutes about how Lubrizol uses these same principles with the work that you do. So we used our scientific method, creating up a hypothesis and designing an experiment, and that applies beyond just putting baking soda and vinegar, right?
Absolutely. At Lubrizol, we make all kinds of different soap, and we make that soap through a variety of different processes. And all of these processes and all the methods we use to develop soap is built on the bedrock of the scientific method. When a new soap is proposed, it's a result of asking a question, like, can we make a product that does this? Can we make a product that cleans a cat better than our other types, or dogs, or gerbils, or shampoos? So there's always starting with a question, and then from there we have a hypothesis on how it will perform, and as we scale it up to production, we test the various aspects repeatedly and consistently, and from there we continue to make observations and new hypotheses based on the performance that we see. So it is an everyday process.
Absolutely. That is great. Well, we are going to be around more this summer here at the library and also with some friends from Lubrizol, so we hope that you'll tune back in. And now I've got some cleanup to do. I don't know about you, Todd.
A little bit less here. A little bit less.
All right. Well, until next time, thanks for tuning in, guys. Bye.
All right. Goodbye.